Electric current and its effect. Learning about uses and effects of electric current. Heating effect of electric current. Activity. Take an electric cell, a bulb, a switch, and connecting wires. Make an electric circuit. We will use only one cell. Keep the switch in the off position. The bulb will not glow. Touch the bulb, it will be cold. Now, move the electric switch to the on position and let the bulb glow for a minute or so. If we touch the bulb, we will feel it warm. If we touch the bulb in off position, still it is warm. This is the heating effect of the electric current. An electric room heater or an electric heater used for cooking contains a coil of wire. This coil of wire is called an element. You may have noticed that when these appliances are switched on after connecting to the electric supply, their elements become red hot and give out heat. The electrical appliances such as immersion heaters, hot plates, irons, geysers, electric kettles, hair dryers have elements inside them. The amount of heat produced in a wire depends on its material, length, and thickness. Thus, for different requirements, the wires of different materials and different lengths and thicknesses are used. An electric bulb is used for light, but it also gives heat. This results in the wastage of electricity. This wastage can be reduced by using fluorescent tube lights. Fluorescent tube lights in place of the bulbs. Compact fluorescent lamps, CFLs, also reduce wastage and can be fixed in the ordinary bulb holders. The wires used for making electric circuits do not normally become hot. On the other hand, the elements of some electric appliances become so hot that they are easily visible. The filament of an electric bulb gets heated to such a high temperature that it starts glowing. If a large current passes through a wire, the wire may become so hot that it may even melt and break. Wires made from some special materials melt quickly and break when large electric currents are passed through them. These wires are used for making electric fuses. In all buildings, fuses are inserted in all electrical circuits. There is a maximum limit on the current which can safely flow through a circuit. If by accident the current exceeds this safe limit, the wires may become overheated and may cause fire. If a proper fuse is there in the circuit, it will blow off and break the circuit. A fuse is thus a safety device which prevents damages to electrical circuits and possible fires. Fuses of different kinds are used for different purposes. One reason for excessive currents in electrical circuits is the direct touching of wires. This may happen if the insulation on the wires has come off due to wear and tear. This may cause a short circuit. Another reason for excessive current can be the connection of many devices to a single socket. This may cause overload in the circuit. These days, miniature circuit breakers, that is MCBs, are increasingly being used in place of fuses. These are switches which automatically turn off when current in a circuit exceeds the safe limit. You turn them on and the circuit is once again complete. Magnetic effect of electric current. We know that the needle of a compass is a tiny magnet which points in north-south direction. When we bring a magnet close to it, the needle gets deflected. The compass needle gets deflected when the current flows in a nearby wire. When the current flows through a wire, the wire behaves like a magnet. A scientist called Hans
Christian
Ørsted noticed the deflection of compass needle every time the current was passed through the wire. So, when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. In fact, an electric current can be used to make magnets. Electromagnet. The coil behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. The electromagnets can be made very strong and can lift very heavy loads. The electromagnets are also used to separate magnetic material from the junk. Many toys also have electromagnets inside them. Electric bell. An electric bell has an electromagnet in it. The circuit of an electric bell consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. It then pulls the iron strip. In the process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. The coil is no longer an electromagnet. It no longer attracts the iron strip. The iron strip comes back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated in quick succession. The hammer strikes the gong every time the current is completed. This is how the bell rings. Thomas Alva Edison invented the electric bulb. He made some 1,300 inventions, including the electric bulb, gramophone, the motion picture camera, and the carbon transmitter, which facilitated the invention of the telephone. Summary. Wires made from some special materials melt quickly and break when large electric currents are passed through them. These materials are used for making electric fuses which prevent fires and damage to electric appliances. When an electric current flows through a wire, it behaves like a magnet. A current-carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. That is all in this lesson. Enjoy learning.